think about computers, there's a lot of terms that come to mind. Information technology, data processing, data crunching, informatics. A lot of stuff, if you think about it, deals with data, which is why for today's lessons, we're going to go ahead and start there since it's a great place to start. Hi there, I'm Roy, and welcome to My Code Corner, where I take a hands-on approach to topics in computer science. And for today's episode, this would be episode 2 of my Swift language series, talking about types and variables, those things that actually hold data. Before we actually jump into everything, let me invite you to join the channel by hitting that subscribe button and hitting the thumbs up if you like this, because it lets me know people are actually interested in this. Now let's go ahead and start taking a look at some basic terminology before we actually get our hands dirty. One of the things I wanted to do before we actually start talking about types and variables and whatnot in Swift, I wanted to actually break down some basic terminology that I will probably throw as I talk about this topic. First one would be talking about memory usage. Now, memory in Swift is handled for you. It's not like some of the other languages where you have to be really concerned. Well, you have to manage it yourself. You should always be concerned about memory, especially for languages like Swift that actually started off as a mobile device language. So while you might not have to manage this on your own, it's always good to have this idea of what it means. So the first thing I want to talk about memory-wise is the bit. Now the bit is the smallest piece of computer memory. There is no way to directly access a bit. There is a ways to get to the information, but it is a very, very small. It basically holds one value, either a 0 or 1. Bits actually make up what's known as bytes. Now bytes are your smallest addressable piece of memory. A byte consists of 8 bits, and when I mean addressable, it might not be addressable in this language like it is in others. It is still, whenever you're dealing with, it's kind of the smallest piece that you can actually deal with without going through some special hoops, basically. The next thing is the word. Now, the word is really based on your computer architecture. For example, whenever I shoot on my PC or I shoot on my Mac, all of these are now 64-bit machines. 64-bit means that's how many bits makes up a word. That would be 8 bytes, because there's 8 bits in a byte, 8 bytes in a word, 64 bits. This is typically the size that the largest, basically, data types hold, but you will find out, at least in Swift, there is something that's a little bit different, and we're going to go into that with this lesson. But understand that typically when you're dealing with machines, the word is the natural size of that machine. So when you hear of an 8-bit machine or a 32-bit machine or a 64 like we're dealing with now, that's the size of a word. Now, there are 2 things that you're going to deal with, and we're going to deal with them in this episode. There is the concept of a variable and the concept of a constant. Both of them mean roughly the same thing. The only thing that's different is whether or not you can change them. A variable being a bucket of memory that holds a value that you can change. The constant, same bucket of memory, but the important thing is that once it has a value, that value can never be changed. Really good for values that you want to make sure to set that can never be overwritten. The third thing I will mention, and I use this a lot, and actually I did not include this in my C++ discussion, but there's this concept of a literal. And literal, while the variable and constant are the buckets that holds data, a literal would be the value itself. So if it's a numerical literal, it's going to be a number. If it's a string literal, it's going to be the string. So these are the values that actually sit in variables and constants. They're also can be used throughout also, and I'll call it out whenever we run into it. Just wanted you to know that literals are the data itself. Now, when we're dealing in these variables and constants, they are buckets of memory. Now, in most languages, those buckets have to be told what basically can fit in those buckets. That is known as a type. So you're going to have a number types, you're going to have character types, you're going to have other types that we'll go into. But basically, it is just there to tell you what kind of data can now fit in this bucket. And that leads to actually the last term is type safe, or being type safe or type safety. Whenever you actually say, a bucket is going to be a numerical type, type safe means that whenever I give you a variable that I say that's going to hold a number, you're not going to see a string in it. A string being a set of characters. That type safety, it's there to prevent your programs from crashing on runtime, when you're actually out in the field. Typically, and Swift is very good at this, anytime there's problems with a type, it will find it during compile. Because finding an error during compile is much better than someone finding it after you've released it to the App Store. Their program crashes, boom, 1-star review, never recover from it. This is actually good because you want to fix those errors as soon as you can, basically as close to building the code as possible, because the further down an error goes down the path to release, the more expensive it is to fix. And expensive would be basically time. So Swift is a very, very type safe language. Most errors are found in compile time. Matter of fact, it's very hard to actually do something that will trick the compiler to not allow a be type safe. There are small cases, but as we run into them, and we're not going to run into them any today, but there are small cases that you can pass something that will basically cause a runtime issue. But it's going to, one of the nice things about Swift, it will put the onus on you. You will have to make that conscious statement that I know I'm going to accept the danger that what I'm doing could potentially cause runtime error. That's it for terminology. Now let's go get to the fun part. Let's get to the code. So let's go ahead and crack open the compiler. All right. So we're going to go ahead and start. You could actually use your same Hello World program for this simply because we're just going to experiment a little bit. I'm going to kick the tires and let you see how do you declare a variable, how do you declare a constant, and really what are the types. I will tell you that one of the nice things about Swift is that it is very, very beginner friendly. So to create a variable, and anyone who's ever written Python or JavaScript, some of this will look real familiar. Not all of it, but some of it will. But to create a variable, uses the keyword var, short for variable. Now, variable you're going to name, of course it's going to go ahead and start trying to write it for me. You're going to give it a name. Now, the nice thing about Swift is this name can be anything, except it cannot have mathematical characters in it. It cannot have arrows in it. And there's certain keywords that your variable cannot be named. Unlike a lot of different, like Visual Studio or whatnot, you can use Unicode here. As a matter of fact, well, let's go ahead and, before we even go that, let's go ahead and, I'm going to create one called any variable. Create any variable equals 1, 2, 3, 4. Ignore the trying to complete. That is Xcode trying to help me out. Sometimes it'll help out too much. Be very careful about that. But in my case, I just want to type it out directly so we can talk about it. But this would be any variable is the name of my variable, and I'm setting it to a value of 1, 2, 3, 4. If you are from some of the other languages, Java, C#, C, C++, the likes, you have to declare what type it is. Now in Swift, most of the time, it will infer what your variable type is. Now, if you notice, I do use camel case. The advantage that you have with Swift compared to some of the older languages come with a lot of baggage. A lot of people have developed a lot of different styles. Whereas Swift, since it does come from the Apple development world, people tend to follow that same style. They kind of follow what Apple did. And even when it goes to the Windows and the Linux and whatnot, kind of the style has been set. So camel case is very, very common. Of course, camel case would be where the first word in your variable name is lowercase. Every word afterwards is uppercase. Now you can use Unicode, and what I'm going to do, if you do a Control Command space, you can pop up your character editor here. Now, the reason why I did it, and the reason why you're actually looking at these emojis, is what's really kind of cool is I can actually have variables that are emojis. Go ahead and put that space there. And I'm going to go ahead and name this one, call him smiley face. Why not? It did what I wanted to do. And if you notice, I'm not getting errors. Matter of fact, if I hit run here, before you saw the errors kept popping up. Right now, there's not saying any errors. I should, whenever I hit run, it's going to say hello world. It won't say anything else. Build succeed. There's my hello world. Exit code 0. This did not crash. So this is perfectly valid. Nice little story. Whenever I started working with Swift, probably like most people, we wanted to write a bunch of programs that actually used emojis. So we were going to have emojis in our code. Just experience, I'll tell you that while it's perfectly valid, matter of fact, I can even print that out. I can put this here, drop this in the middle here. And so if I hit run here, it should say hello world and it should say smiley face. Smiley spelled wrong, but that's okay. And you notice it still used my variable. I will say that while it's neat to do every once in a while, it's neat to do the first time. Matter of fact, play with this a little bit just to get it out of your system. Because if you notice, I have to hit Command Control Space every single time I want to pull this one up. I mean, I could just do a copy paste with that character and do that there. This does get very, very monotonous. It's also not every emoji is covered. Not every Unicode character is covered. So you got to be very careful when you're doing things that is not your plain ASCII set. The other problem is that when you switch to Linux or Windows, whatever, you're probably going to be coding in something like a Notepad or some other, maybe Ultra Edit or something. Who knows? Could be VI even. You might not be able to have that same character set that you're going to have when you're developing this on a Mac. Get it out of your system and probably never do it again. So I'm going to just comment these out. Actually, I'm just going to delete them. If you're working in a situation where potentially, let's say you're dealing with mathematical formulas, or you're dealing with, I don't know, medical terms, or you need that umlaut, or you need an enye, or you need something that's in a Unicode, you can actually still get to it from here. Matter of fact, I'd go down to this bottom here. Most of these are just your emojis, but I'm going to scroll with this little caret here. You notice this kind of looks like I guess it's a box within two boxes or whatnot. It might even be supposedly a keyboard. I don't know. You can get to this. This is the same character viewer that was before. It's just a little bit more pronounced, and it'll actually break out to, the frequently used or the emojis, or there's your arrows. Remember, your arrows you can't use. You might look at some of the Latin characters. There may be some pieces here that you want to use because it's in a language that you want to deal in, or you want to, I had before here the math symbols, because when you're doing math, there's a lot of the Greek letters here. Maybe these are things that you would use. I would definitely not use them unless people that you're developing with, your team, understands it too. Readability is very important in Swift. And so if you do something just to confuse people, like putting little smiley faces or using this alpha character, this lowercase alpha character there, if it doesn't mean anything to someone else, you're going to lose the goodwill of doing this, making it readable for them. So again, you can use a Unicode perfectly fine. There are a lot of cases that you don't. Matter of fact, that's the nice thing, is that if you're trying to use an emoji or you're using a Unicode that's not allowed, it's going to give you an error even before you hit compile. It's going to detect it because it's basically running a constant live compile anyways. So if you run into something you can't use, don't use it. But be very cautious. Only use things if it's readable. With that being said, I'm going to go ahead and close this down. But that's it when it comes to a variable. We'll go over exactly the types and whatnot here next. But before I do, since I mentioned constants and variables are basically the same thing, it's just whether or not you can change it. The difference between a variable and a constant is one word. So this would be a variable, call it any variable equals 1, 2, 3, 4. I can also say let, call it any constant, equals 1, 2, 3, 4. So I'm basically saying let any constant be 1, 2, 3, 4. That's it. This right here is a constant. When it comes to difference between variables and constants, again, if I say any variable equals 5, 6, 7, 8, you notice no error. But if I do any constant equals 5, 6, 7, 8 and hit return, I get this error. It says it cannot assign a value, my constant, since it's a let constant. Again, you can change a variable, you cannot change a constant. That's the only thing. There will be a case where you can set a constant without a variable. Understand that while you can set a constant without a variable, you cannot use a constant that has not been initialized yet. So really you can create it or declare it, but until it's initialized, which is what this assignments are doing, you can't use it. That's it when it comes to constants. Now I'm going to focus on variables again. Realize that everything I'm doing with variables, I can do with constants. You just can't change the value. Now, whenever, let's do that. Let's go ahead and print any variable. Always hit that tab, make it a little bit faster. And of course, this one, what should it do? It should print 1, 2, 3, 4. And it does. There it is, 1, 2, 3, 4. This is if you only want to print the one value. You can print pretty much any variable. You can print any constant. It's going to convert it into some manner that it can be used. Now, what would you want to do if you wanted to put it like within a sentence? For example, we'll get rid of this. Let's say I want to print my variable contains, kind of doing it for me. My variable contains, and then I want to print what this variable is. There's a thing that's known as string interpolation. What string interpolation, and if you watched what it kept trying to do, because it's going to try to help you as much as it can. But if you noticed, there was the backslash. Always have to remember which way that goes. And then you see that open paren, close paren. Between those, if I put my variable, so my variable contains slash in parens any variable, what it does is it takes whatever that any variable is and turns it into the string to fit here. So I can actually run this and it should basically say my variable contains 1, 2, 3, 4. This is known as string interpolation. This is used all the time. Matter of fact, there's a lot of concats and stuff like that a lot of the libraries use. This is the easiest way to do this, and you will see this in code all the time. But basically what it is take the variable, surround it with parentheses, and put this slash, which is basically an escape character. That's it. String interpolation. So you got a nice word for something that's really super, super simple to do. But we've been talking about this variable. We even talked about constants. We talked about how we can print it. We talked about string interpolation. We don't know what this variable type is. Well, here's the nice thing. There is a way to find that out. Actually, that just reminded me something else. So we have mentioned any variable, the var any variable equals 1, 2, 3, 4. We know this is a numerical type of some sort. Now, what if I wanted to take that any variable, and let's say we set that to, let's say we're going to set it to hello world, right? Now, this is that type safety that I mentioned. Remember, we have a type. We declared this type and set it to this value. It inferred what the type is, and the type is obviously a numerical type. When we try to go with a non-numerical, which is this string here, which when you see something between two quotes, it's a string. We're trying to reassign a string into this variable that's of some sort of numerical type. And you notice I get that error. This is type safety at work. Since I know any variable is a numerical type, I can't put a string into it. I couldn't even do a string interpolation and try to set it. That type is set with this line right here, and it cannot be changed. So this will error, which it is. And if it errors like here, it means if I hit run, it will not build. Again, type safety, catching the error before you build, or at least during the compile time. So we're going to go ahead and get rid of that. But I keep talking numerical types. But what is this numerical type? Well, what's nice is there are methods. And the first method we're going to talk about is the type method. And the type method, and of course, this is another one of those Swift things, is trying to make it very readable. If I say type of, you see it says any variable. What does that mean? Well, actually, that means nothing, because as you notice, I'm not using it, right? There's nothing here. I'm calling this, but I'm not doing anything with its output. I'm not saying what this is. So really what I want to do is, like everything, we're going to print it because we want to see what it is. So I'm going to go ahead and put a type. So if I read this, print the type of any variable. Very straightforward. We're reading it from the left to right, standard English, minus no spaces. So print type of any variable. And what this will tell us is what type the system thinks this is. If I hit run, it tells me it's an int, being short for integer. Now, if you come from a lot of the other languages, the Algol type languages, which is the Java, C#, C, C++, there's a number of them out there, you probably recognize that int. Word's the same, but if one thing you may notice that's different here compared to, like, let's say C++, since I'm teaching that in my other language series, you notice that int is capitalized. And if you are taking that C++ course at the same time, if you remember whenever I talked about styles for variable names, or styles for names in general, there was the ones that started with capitalize. Anytime you're looking at something that's capitalized, it's typically a structure or a class. Basically, they are rich types, which basically means they are more than just values. When it comes to Swift, this int is a rich type. It is actually a structure, but that structure has a lot of methods that are actually built in. In C and C++, you have to use things like the standard libraries to help beef it up. Other languages, Java, there are versions where there's a lowercase one and an uppercase one. Actually, with Java, I think it's integer. It's been a few days since I've written some Java. But the integer and uppercase and lowercase are different. Lowercase being just the raw data type, the uppercase being that, in that case, it's a class. It's another thing that's different between Swift and those other object-oriented languages. They use classes more. With Swift, it uses structures more. It's just, we'll go into that in the future. It's a little bit deeper than what I want to talk about today. But if you notice for here, it's basically inferring that this is an integer, the rich data class. There are no base primitive data types in Swift. Everything is rich data types. Makes perfect sense. This is a newer, more modern language. You know that not only do you have to put something in a bucket, you're probably going to do something with it. So why not kind of glue all the methods to that data type when you declare it? That's what Swift does. So it's kind of built in for you. And we're going to use some of those, I don't know, probably not this lesson, but in other lessons we are going to use it, starting actually with the next one. But we know this is an integer. Didn't have to set anything to it. We just basically, it saw that there's a number afterwards. When that number 1, 2, 3, 4 popped up, that's an integer. I'm declaring it. There you go. What if I added a 0.0? Turn that integer into a floating point number. We know integers in other languages were only real numbers. They weren't floats. They weren't doubles, which is what those other ones do. So if I take this, put a decimal 0, and hit run, what's this one going to be? This is a double. Again, capital D. This is a rich data type. Notice it's a double. And a double, especially if you're looking at C++, a double is twice the precision of a float. Swift knows that it wants to give as much precision as possible, because those precision is where a lot of the overflows and those type of conditions occur, and we'll talk about that next lesson. But it's going to try to give you as much data as possible so that you don't have it run into those conditions. So if I have just a 1, 2, 3, 4, that's an integer. 1234.0, that's a double. What about, before we try to do this, we have that hello world. Now, because I'm doing it when I'm declaring my variable, this is not going to error because I'm not trying to re-put data into it. So I'm just going to hit run here, and what does it do? This is known as a string. I kind of mentioned it before, anything between quotes is a string, and that's what it is in Swift also. String has a ton of modifiers and a ton of methods on it. I could probably do 3 or 4 episodes on just what you can do string alone, and we will in C++. We may here. We'll pull them in as we go. We're not going to devote an entire group of lessons to it because you'll get bored, and I don't want you to get bored. I want you to stay along and be part of the channel by hitting subscribe. And then the last one, what if I say any variable equals true and I hit run? And this tells a bool or a boolean. Boolean being that true false. That's all it can hold. Now I kind of inferred a little bit that this was the last one. So if you noticed, when it comes to the basic data types, and basic in air quotes since they're all rich data types, the basic ones that Swift will infer: int, double, string, and boolean or bool. There are other types. Now, I did mention before we had this 1234.0, and if I hit run, you notice it's a double. But what if we don't want to use a double? Because, one of the thing about any of these is they consume memory. Now, from a development point of view, unless you're really dealing in tight, constrained, most of the time you don't care about what the memory is. I always care about the memory because I've worked in embedded systems where I need to keep it as tight as possible. Most of the time, you don't care. So declaring something as a double, it's going to, let's see. Teaching you a different method because most of the time you don't care about memory sizes. Well, there is a way you can tell what size of a variable is. Using this memory layout dot size. So memory layout dot size of value, any variable. This will tell me the size of my variable. Now, once again, just calling this does nothing. Let's go ahead and print this one out like we did the other one because we want to see what it means. So we're going to print size of value, any variable, and I hit run. Now, the output of this size method tells me how many bytes. And notice this is 8 bytes, 64 bits. So this is this is a word size. Now, what if I didn't want to use a word? Maybe my variable is going to only be this size and I don't really care. Maybe I only have 2 or 3 places. Maybe I'll do, say, 0.012, right? And I'm not going to let it complete with more numbers because it's going to try to guess, and I don't care. And I hit this, even though I increase the size there, my size stays the same because what it does is declares the bucket and puts it in the bucket. Now I know this is not very precise. This is actually quite a small number when you're talking about 64 bits. So maybe I don't care about something using this much of that. I don't want to use 8 bytes of memory. Maybe I only want to use half of that. If you are taking C++, you might remember half of a double is what's known as a float. Well, here's the funny thing. It means it's exactly the same thing in Swift. And in this one, I can actually use a concept that's known as type annotation. And how do you do type annotation? Nice fancy sounding word. After the variable name, I can put a colon and actually specify float. Matter of fact, if you notice, as when this popped up, let me back this up again, there's actually multiple different floats I can use. I can use a float, float 16, float 32, and a float 64. Why I'd use a float 64 and not a double? Actually, it matters how the decimal precision is different between double and float. But know that there's actually multiple types here. And of course, the float that we're going to use is this basic one. The 16, 32, or 64 tells you how many bits of data are you going to use. Now we're going to call out just the straight float, and I'm going to hit run. And you notice the variable contains exactly the same number. It's not so large that you're going to get an error not in code, but an error in precision of your number. But you also see that it does say it's a float, and it's only 4 bytes, so it's half the size. You can only do type annotation for something like a float, because if you don't give it a type annotation, it will declare as a double. You can do a type annotation of a double. Matter of fact, if I hit run here, and it's going to do the same thing as when I didn't have type annotation. And that's a good thing to point out, is that typically let Swift take care of that itself. If something like this, where you're going to annotate it with a type that was going to infer anyways, don't put it. This is actually bad style. It's to so many more characters that you have to type. But the int, double, string, and Boolean don't have to use type annotation. Let it handle itself. Only in cases like float would you do type annotation, because it's not going to actually interpret it as a float. You have to call that out specific. There are other ones, and while we're at it, I'm going to show you. Now remember, we did this before. This was my integer. How big is my integer? If I hit run, my integer is also 64-bit. What if I want less than 64 bits? Well, there is type annotations there. Now, it's not going to be like C and C++, where you had short, a long. You won't have those. But what you will have, bring this up, if it was just an int, the 8 bytes, no annotation. But if you only want 4 bytes, do the int 32. If you want 1 byte, int 8. 2 bytes, int 16. Int 64 and int, same thing. Notice that you can actually have an int 128. This is actually putting 2 words together. So can't do this in other languages, but you can in Swift. Other thing that you can do, let's say in this case, we know this is a positive number. What if we want to make sure that it's only positive? In the case of C and C++, remember there was that keyword unsigned. Well, in Swift there is too. Just put the U in front of int. There's the uint8, uint. You have to use type annotation here, because it will not ever figure you're going to do an unsigned number. Of course, there's uint32, uint16, uint64, and a uint128. So those are all, and of course, you see this S beside these, tells me these are all structures. T's mean templates. We'll talk about that another time. But these are all raw data types. They're still very rich. They will have all of the methods that like an int does, but the system will not actually interpret whatever you put on the right side of that assignment as the number, as a uint or a int 16. You have to call that out with a type annotation. There is another way you can do type annotation. After you assign a variable, you can say as uint32. So instead of that colon here before the assignment, you can say any variable equals 1, 2, 3, 4 as a uint32. Again, reads from left to right. And if I hit this one, see, it tells me it's a uint32. It tells me it's 4 bytes, and there's the value. Doesn't change anything there. So we've done double and float. We've done all the fun versions of integers, and there's a ton of those. What else did we do? Well, we actually did Hello World. Now this is where it's going to get fun. And I'm going to show you 2 things here. First off, I'm going to hit Hello World. Notice it's a string, and it's 16 bytes, 128 bits. And I know you're saying, Roy, but 128 bits is not a natural word. And I would say, yes, you are correct. You also look at this and go, but also, if I think back in C and C++, every character was 1 byte, and there's not 16 bytes, 16 characters here. Here's what's also, what if I did this? Make this string nice and long. I could actually do a lorem ipsum and whatnot. Make it as long as I want to do. I'm going to hit return, or sorry, run. And even though my string is much longer, it's still 16 bytes. Let's make this even longer. Take that shortcut way of doing things. Make this one nice and long. And I hit run once again. And it's still 16 bytes. So it's not changed whatsoever. Well, as you can tell, this is a string. And when it comes to strings, this is where Swift does a little magic. In the case of strings, you can have this be huge. It really doesn't, you can keep going on and on and on and on and on. Swift will do one of two things. So you're going to allocate this 128 bits. This is allocated during compile time. And depending on how long your string is, the two things it will do is either one, uses this really, and I don't even know the details to it, I just know it does it. It will use this real magical encoding technology to put whatever I put in my, basically between my quotes, into those 128 bits. Realize also that these characters here are not 8-bit ASCII characters. This is all Unicode. Unicode actually does all of its character encoding in 16 bits or 2 bytes. So whatever you see here, if let's say this was 200 characters, it would consume 400 bytes, which is definitely more than that 16 bytes you see here. So if it can, it will do an encoding way to actually crunch whatever that string is and put it into those 16 bytes. If it cannot, and it makes this decision most of the time at runtime, because you're not guaranteed that that value will be set in compile time. But if it can't encode and put that string into those 16 bytes, it will actually find a place of memory to put that string. And then in those 16 bytes, it will create a pointer to where that string lives in memory. Pointer is a technology, or it's a term that's used heavy in a lot of different languages. You deal directly with that in C and C++, which is what makes that language so hard. It's one of those things that if you mess it up, that's where things like memory leaks occur. Sharp takes care of it for you. It handles memory. I say so does Java. But Swift is real good at this because it will only create and manage that memory if it has to. So if it can, it will put it into those 128 bits. If it can't, it will put it somewhere and use this as a reference to where to get that data. It's one of those things, it's good to know. You don't have to worry about it. It's the magic within Swift. Realizes that it's going to do it for you. Nothing you have to do. I'm going to cut most of this. And I'm going to just have this any variable, just one character, h. Now if I hit run, it's still a string. It's still 128 bits. It's definitely overkill for what this is. But let's say you're developing and you know that whatever this variable is going to have will never be more than just that one character. In C and C++, there is that concept of a char or a character type. Well, in Swift, you have one too. And of course, it's not one that can be interpolated. It's one that you have to call out. And it's not interpolated, it's interpreted. It's one you're going to have to call out. So I'm going to say colon character base. Now here's something else that's really, really interesting. If I hit run, it does tell me it's a character. It does say what my variable contains. It's still 128 bits. Notice that it didn't change size. Notice a character and a string in Swift are the exact same size. Why this happens is because, once again, it's a Unicode character. It's also, this is what's going to be fun, bring up, and I'm going to let's put little Mr. Pukey Face here, right? I'm going to go ahead and hit run. And you notice that my character, which is still 16 bytes, and my variable contains Mr. Pukey Face. Strings and characters can contain any Unicode characters to include emojis. This is that encoding. So this is, if I remember correctly, and I have to go back and look, it's known as a grapheme encoding. Again, this is nothing that you ever have to remember. This is, if anything, it becomes a bar bet. If you want to ask one of your friends that knows iOS, what kind of encoding does Swift do for characters? And if they don't say grapheme encoding, they owe you a beer. But you can encode whatever is here into those 16 bytes. With character, you're guaranteed there's not going to ever have to be a memory reference to somewhere else. It will always be encoded into those 16 bytes. Strings, not so much, but characters all the time. And of course, let's say I don't want to do this a little different. Of course, do Mr. Pukey Face as character, hit run, and it does the exact same thing. So that's it when it comes to types and variables. Swift is pretty straightforward. Most of the time, it's going to do the work for you. If you need a numeric, unless you need specifically where you want to basically constrain the amount of memory used, or you want to ensure that you want that number to be an unsigned number, it will convert it to an integer, and none the wiser. It's just magic. I would say, especially for things like unsigned integers, that would be one of those type safety things to be careful about. Is, if you want to make sure that you can never use a negative number, call it out as an unsigned. Therefore, the language will pick it up and probably will find it in runtime. In compile time. If not, it will definitely find it in runtime, and there is ways to handle that and to handle that gracefully. If you're dealing in strings, like what's in this hello world, let it call it out as a string. There's actually really nothing else, no other way. We will talk about collector types a little bit later. I wanted to do the basics one first. But if you're dealing with strings, you just say var any variable or let any variable equal and put the string in, and it will just handle it for you. If you just want it as a character like this, either the colon character on the left side of the assignment equal or as a character on the end, they both work. I typically do the colon type simply because it reminds me more of when I'm coding in C++, but I can actually see as character being more readable. When it comes to Booleans can only be Booleans. I mean, it's going to be true or it's going to be false. There is no other value it can be. And then when you're dealing in non-real numbers, unless you really want to constrain how much precision, just let it be the double. Double is as nice a precision as you're going to deal in. And most cases probably will be more precision than you ever need. So that's it. Of course, remember, whenever you're doing any sort of printing strings, this string interpolation, where you do a slash and then in parens after that slash, this backslash is your escape slash. You put a paren, and inside that paren, you put your variable. Only one variable. You can't really do equations in here. We'll play more with this, but it's pretty straightforward. And if you're ever wondering, this type of will tell you what type that variable is, and that memory layout.size of value will tell you how many bytes. Do you care about that most of the time? No. But it's always good for lessons like this so that you actually get an understanding, because understanding your memory use is very important. It's one of those things that old guys like me back in the day, when when iOS first came out and we were coding it in Objective-C, you had to be very, very careful about your memory use, because old iPhones did not have much memory. So you always wanted to be very careful. And that's why those of us from the embedded system world and the old school, where we were coding in systems that did not have much memory, we looked for those memory things. So it's a good thing to know what it is. Is it important? Not really. It's just, Again, it's a good bar bet. So if someone ever asks you, well, how much memory are you using? How much memory is that? You have a way of doing it. So let's go ahead and review what we covered. All right, so in a quick summary, we did talk definitions, including memory terms. Good to know, not necessarily learn programming. Good to understand how things, because I'll tell you, especially as architecture changes, these sizes do start changing. Swift is pretty consistent though. And that's been one of the nice things is that, in some languages, i.e. C++, it will change from platform to platform. Swift doesn't do that. So whatever the size is the size it's going to be. We did talk about how to basically define a type and a constant. Of course, that would be the var for a variable and a let for a constant. Otherwise, it's exactly the same. How to name a variable. We did talk about the camel case. One thing I will call out here is make sure in your variables, don't typically name them after reserved words. These are words that are present in the language. There is a way to do it, and I did not cover it simply because it's bad practice to use reserved words in variable names. If you have to do it, I would say Google it. But while you're Googling it, think, do I really need to do this? Because I recommend don't do it. It's a great way to get yourself in trouble. We also mentioned that when naming variables, you can use all of Unicode. You can use emojis. When it comes to coding in emojis, it's fun. Do it a couple times to show you can, and then don't ever do it again. Till you're showing someone else that you can do it, and then tell them don't ever do it again, because it does. You get kind of tired. The novelty wears off pretty quick. But when it comes to Unicode, I would try to stick to the 8-bit ASCII as much as you possibly can, using the characters that are on your keyboard unless your team that you're working with understands what you're trying to say. Because, there are terms that will have like Greek letters in them, or, potentially you're writing in from another country. And, while I might not know kanji, I don't know, I know some German, I know some Spanish. I don't typically write my variable names in them, but I could. I could add the umlauts and the enyes and whatnot. I probably wouldn't in my case because the teams I work with don't. But if I was coding in Germany, I'd probably use a lot of the German characters just because I can. I did show how you could drop a character into a string. There is a way to use a /u to add a Unicode character into a string. Maybe I'll cover that another time. But realize that you can put Unicode characters in strings as straight as you can any ASCII text. We did talk about type annotation and special types. Those special types are those ones where the compiler doesn't actually figure out what you're using. Those 4 basic types of int, string, double, and bool or boolean. All the other types where you're doing the uints or the int32s or the floats or the characters, those are special types. And the reason I call them special types, other than that's what they're called a lot of times, they're also ones that you actually have to use type annotation. That would be either ending the line with an as whatever that type is, or the var variable name : whatever that special type is equals your value. Realize that adding a type annotation, if it's one that's automatic, don't do it. It's bad style. It won't crash, but you'll actually look like, oh, look, that's a beginning coder. We want to get you past beginning coder stage, so I would suggest don't do it. It's bad style, plus it saves a few keystrokes, so you'll be using those other places. And then we talk about string interpolation. This is actually where you can turn any variable into a string, and that's with a \paren variable name closing paren. That's it. Again, Swift is pretty straightforward when it comes to types and variables. We're going to pick up a lot of these. There is actually a lot of different types and variables. As we run into them, I'll call them out. Collector types are one of. There's actually quite a few, but they're ones that when we call them out, we're actually going to call out the methods they use, because remember, types in Swift are rich types. They are not only just a data holder, they're a data holder along with a lot of different methods to do stuff with it. This is a modern language. This is not something that was written back in the 70s and 80s. This was one that started being written in 2010, wasn't released in 2015, so this one is now over a decade old. Definitely got a lot of miles under it. A lot of people have coded to it. It's actually getting quite a bit robust, and one of the things they know you need methods on data. With our next session, we're going to talk about math operations. Again, going to be pretty straightforward. If anything, I'm going to unteach you some things that you might have learned in other languages. But I hope you enjoyed this one. Could get a little long-winded sometimes simply because I do love going into these. I'll go into little tangent stories every once in a while. I'll cut a lot of those out, actually. But I do enjoy taking this time with me, learning a new language, or enforcing the language if you've already learned before. We will get through these basics pretty quick. We'll start getting into some of the more advanced stuff probably in faster than we ever did in C++, because C++ being such a large language to learn and a hard language to learn, whereas this one, very beginner friendly, and it goes quick until it doesn't. We'll get to a point where this one will feel a little bit rougher, but hopefully together we can get through that pretty quick. I appreciate the time you've taken to learn this and listen to me ramble. And if you like this, definitely join the community, hit the subscribe. As always, hit the thumbs up if you enjoy what I'm doing. Even if you don't, I'd appreciate it. And if you got any questions or comments, comment section below. I do answer comments because, again, my goal here is to impart the knowledge that I've done in the last 30 some years. God, it's hard to believe it's been that long. But I enjoy you coming along. And until next time, happy coding.